A stepper motor is a motor which spins by moving between a series of discrete steps, which allows the motor to precisely control both speed and position. To use a TB6600 stepper motor driver, we need a suitable stepper motor, power supply, and wires. The stepper motor can be any two-phase stepper motor that has 200 steps per revolution and a rated voltage of less than 42 volts and a rated current of less than 4.0 amps. For the power supply, it needs to be a DC power supply that applies a voltage greater than the stepper motor but between 9 and 42 volts. For this video, I am using a NEMA 17 stepper motor. My motor has a rated voltage of 3.6 volts and a rated current draw of 1.0 amps. For this video, I am also using a DC power supply that provides 12 volts and 3 amps. Now we will wire the devices together. Follow the diagram and table shown on the screen to make the connections. When connecting the stepper motor to the driver, you need to connect the two leads of the same coil to the two connectors which share the same coil symbol on the driver. To determine if two leads share the same coil, connect the two leads and hand spin the shaft. If the shaft spins freely, the leads do not share a coil. Otherwise, the two leads do share a coil. Next, we need to configure the driver using the switches on the side of the driver. Based on the chart, flip the switches to set the current limit in micro-stepping mode. Make sure the current limit is lower or equal to the rated current draw of the motor. As for the micro-stepping option, micro-stepping allows the motor to stop in between its discrete steps. This allows the motor to spin more precisely, but with less speed. In my case, I am limiting the current draw to 1 amp, and I will not be using micro-stepping, at least for right now. Now, we are ready to program the Arduino to run the stepper motor. To make the stepper motor spin, first, we have to set the enable pin to low voltage, which enables the stepper motor driver. Then, we have to set the pull pin to high voltage, which makes the stepper motor rotate by a single step. To make it rotate another step, we have to set the pull pin to low voltage and then set the pull pin to high voltage again. Of course, we cannot do this instantly, or the driver won't register the signal. We have to wait around a few hundred microseconds between sending signals, but if we keep switching the voltage of the pull pin between low and high, we will cause the motor to continuously spin clockwise. If we want to spin the motor in the counterclockwise direction, we need to set the voltage of the direction pin to be high, and to spin the motor back in the clockwise direction, we set the voltage of the direction pin to be low. If we want to change the speed of the spinning, we can adjust the time delay. By increasing the time delay between switches, we make the motor spin slower. Let's try to more accurately quantify the speed so we can precisely control it. Rotational speed is most commonly measured in revolutions per minute, or RPM. Rotational speed is a measure of the change in the shaft's angle divided by the amount of time for which the shaft is rotating. By doing a little bit of dimensional analysis, we can calculate the time delay we need to set between switching the voltage of the pull pin based on how fast in revolutions per minute we want to spin the shaft. To find the number of microseconds we need to wait between switching the voltage of the pull pin, simply divide 30 million by the desired speed in RPM and by the number of steps per revolution. Next, we want to precisely control the stepper motor's rotation. I've made a function called rotateBy, which rotates the stepper motor shaft by a certain angle in either the clockwise or counterclockwise direction. We take two parameters from the user, a float called angle and a string called direction. Angle is a rotational angle we want to make in degrees, while direction is either CW if we want to spin clockwise or CCW if we want to spin counterclockwise. Within the function, I've set up a variable called number of steps, which calculates the number of steps needed to spin by the desired angle by dividing the angle by the number of degrees per step. Then, I've set up an if statement to determine the direction pins voltage based on user input. And lastly, I've set up a for loop which spins the stepper motor on the number of steps calculated by the number of steps variable. And here's a full scroll through of the code. As a smaller YouTuber, I am not allowed to post code or links in the description of my videos, which is unfortunate because if you want to use my code, you'll have to manually type everything into your computer instead of using a copy and paste function. So, if you found this helpful, please like, subscribe, comment, and share so I can make my projects more accessible in the future.